Tutorial number 5, question number 1. The 10 kilogram collar slides on the smooth vertical rod and have a velocity of 2 meters per second in position A. Each spring is stretched 0.1 meter. Calculate the velocity of the collar as it passes point B. We already have the initial velocity, which is equal to 2 meters per second. V1 is equal to 2 meters per second. And the spring constant is equal to 800 Newton per meter. We can call the length of the spring at point A, L1, and the length of the spring at point B, L2. So the stretch of the spring at point A is equal to 0.1 meter. L2 is equal to square root 0.4 square plus 0.3 square is equal to 0.5 meter. So the stretch at point B is equal to 0.5 minus 0.4 plus 0.1, which is equal to 0.2 meter. And also the mass of the collar is equal to 10 kilograms. What we need to find is the velocity of the collar at point B, which is equal to V2. Because there is no non-conservative forces existing, such as friction, so the energy is conservative in this case. We will say T1 plus Vg plus Ve is equal to T2 plus Vg2 plus Ve2. T1 is kinetic energy, Vg is the gravitational energy, and V is the elastic potential energy. So delta T plus delta Vg plus delta Ve is equal to 0. So have 1 over 2 times the mass of the collar is 10 times V2 square minus 2 square plus. If you take this as our reference, we will say the gravitational energy decreased in this process, so this should be negative 10 times 9.81 times the change of the height will be 0.3 meter plus 1 over 2 times spring constant, which is 800 times stretch at point 2, which is 0.2 square minus 0.1 square. Because there are 2 springs, so we need to times 2. This is equal to 0. So after we solve this equation, we got V2 is equal to 2.26 meter per second. Question number 2. The collar has a mass of 2 kilograms and is attached to the light spring, which has a stiffness of 30 Newton per meter and an unstretched length of 1.5 meter. The collar is released from the rest at A and slides up the smooth rod under the action of the constant 50 Newton force. We already have the mass of the collar, which is 2 kilograms, and the stiffness of the spring is 30 Newton per meter. And the unstretched length is 1.5 meter. The external force is 50 newtons. What we need to find is the potential energy of the spring at time is equal to 0. So when t is equal to 0, we have LA is equal to 2 meters. Then the stretch is equal to LA minus LO equal to 2 minus 1.5, which is equal to 0.5 meter. So VEA is equal to 1 over 2 KSA square, which is equal to 30 times 0.5 square, which is equal to 3.75 joule. Also, we need to find the velocity of the color at point B, which is VB. So TA plus VA plus the external force done by the work done by the external force, which is this, equal to TB plus VB. So the color starts at rest, so TA is equal to 0. VA is equal to all the potential energy, is also the gravitational energy and the potential energy from the spring. We can set this as our reference, so this is equal to 0. Equal to 1 over 2 times 30 times 0.5 square, which is equal to 3.75 joule. Also, we need to find the length of the spring at point B, which is equal to 1.5 square plus 2 square, which is equal to 2.5 meters. So the stretch at point B to 2.5 minus 1.5, which is equal to 1 meter. So we can calculate VB. VB is equal to mghb plus 1 over 2 KSB square. M is equal to 2. HB is equal to 1.5 meter. Plus 1 over 2 times 30 times 1 square, which is equal to 44.43 joule. The work done by the external force equal to F times cosine 30 degrees times the change of the column in y direction, which is equal to YB minus YA. So we have 50 times cosine 30 degrees times 1.5 equal to 64.95 joule. So we have TB is equal to TA minus, this is equal to 0, plus VA, the work done by the external force, minus VB, equal to 3.75 plus 64.95 minus 44.43, which is equal to 24.27 joule. And this is equal to 1 over 2 times mass times velocity square. So m is equal to 2, so VB square is equal to 24.27. So VB is equal to 4.92 meter per second. question 3. We need to draw the free body diagram of the collar at point B. So it have the gravity and also the force from the spring, which is Fk is equal to Ks, and also the external force is 50 newtons and 30 degrees. This is 30 degrees, and also the support force from the rod, which is N, and this is Cartesian coordination, so this is X, this is Y. Question number 3. The system is released from rest with the spring initially stretched 25 millimeter. So we have X1 is equal to 0.025 meter. And also we have the mass of the cart, which is 60 kilograms, and also the spring constant, which is equal to 300 Newton per meter. What we need to find is the velocity of the cart after it had moved 100 millimeter down the incline. So we say V2. And also we need to determine the maximum distance D traveled by the car before it stops. So we call it D. Apparently there are 3 stages of the cart. At status 1, it will be rest. After move 100 millimeter down, we have our status 2. So after it stopped, we have status 3. So we would say from 1 to 2. We have our equation T1 plus V1 is equal to T2 plus V2. Because the card is at rest at point 1, so we say this one is equal to 0. And also we set this is our reference, so we don't need to think about gravitational energy. So we just need to think about the spring. That will be 1 over 2k x1 square is equal to T2 is equal to 1 over 2m v2 square plus 1 over 2k x2 square, because the car is moved down the incline, so the gravitational energy will be negative mgh. So x1 is equal to 0.025 meter. What we need to find is x2, so 60 v2 square and plus 1 over 2 300. We need to find x2. If you take a look at this pulley system, you will see that there are 3 strains that actually affect the motion of the car. So the stretch on the spring is equal to 3 times displacement of the car. So we say x2 is equal to 0.025 plus 3 times 0.1. 2 minus the gravitational energy 9.81 times 0.1 sine 20 degrees. So after we solve this equation, we have V2 is equal to 0.382 meter per second. So from 1 to 3, we have T1 plus V1 is equal to T3 plus V3. again T1 is equal to 0, V1 is equal to 1 over 2 300 times 0.025 square equal to, when at status 3, the card is also at rest, so T3 is equal to 0. So we have 1 over 2 300 0.025 plus 3D square minus the gravity potential energy. So it's 60 times 9.81 times D sine 20 degrees. After we solve this equation, we have D is equal to 0.16 meter.